Hello. So now we will discuss inheritance in Python. So this is connected with the classes in Python. And as the name suggests, it is connected with inheritance properties between classes. So what happens in human relationships? Parents give their property to children. So there are certain properties. Properties money for parents, but we'll have something like that in classes too. This goes to children. But children create their own properties. So similar things happens in Python too. So there's a class, parent class, which has its own properties. And there's another class called child class. Okay. So child class will take the properties of the parents. Okay. And it will create some more functions, okay, some more properties. So often we have large codes. So we have many functions. So well, we'll create some class which has basic functions like 50 functions. Then we have a child which will inherit in these 50 functions, but you'll create some more functions. Okay. So example is like humans, okay, like person. So person has a name and age. But so this is basic class. Now we can create a student class, which is a person plus some more properties. So what student has a roll number, okay. It also gets a grade in its during the classes. So these are additional properties of a student. Okay, so like animals have certain common properties, but then some class of animals, like humans, will have two legs. So we can define a subclass called human, subclass called dog, subclass called cows. So they're different properties, but human has certain common things, and then separate class. Anyway, so this is the basic idea. Again, you can see it helps in creating large codes, but I'm illustrating only some simple examples here. So inheritance. So we have parent class or base class, from which another class, a child class, will inherit, and child class is basically inheriting from the parents. Okay, this is hierarchy. Used for creating complex structures. Let's make it a plural. Okay, so in the previous discussion, I had created a class called student, which has fields, name, and roll number. So I want to build from that class. I don't want to give another example. So we'll take this basic, this is the base class or parent class. Now we create a child class, which will inherit these two properties, name and roll number, but it will have something more. So let's think of physics students, each way student. Well, in the next slide, I'm going to put some more properties, but let's just illustrate. So this is a child class, which is inheriting the student class. So what is the parent class is here, where it inherits from parent class. So you see within the bracket. It means a physics student is a child class which is inheriting from the parent class, which is in the bracket, and pass. So do nothing. So at present, the physics student and the student are same. The properties are exactly same. This child class is doing nothing to increase the properties. Okay, child has done basically inherits and does nothing. Now we can create a student SP1, which is of the class physics student, not the student, physics student. Now, since inheriting the student class, so it has two fields, name and roll number, which is Richard and 10. Okay, so please note that I'm not writing SP1 equal to student name and roll number. Not writing that name roll number. I just write like this. And so SP1 is each by student, Richard 10. Okay, so this is child class student stuff 10. Okay, and so student name is Richard. So when I print it, it's going to come as okay, Richard. So this is print. So I have not shown you, but this is a function. Print name is a function which is printing Richard. So each student class inherits the property of student class. Okay, so this is a parent class and child class. At this moment, because I'm using pass, the physics student has no property of its own. It's basically just inheriting the property of the parent. Now let's do something more. So this was student class. Okay. But now I create a physics student. This is a child class. So it is inheriting the student. Okay. Now it should have something more. Otherwise, why should I create a child class? So something more is that we put a physics CPI. So not the full CPI, but only the physics CPI. Okay. I mean the physics, the CPI cumulative point average, grade point average, calculate for the physics courses. So it has earlier two names were there, name and roll number. It has to be there, and these two fields are to be there. So they are part of student, the parent class. So the self dot name will be name, like self we used before. Self dot roll number is roll number, but in addition to that, we have physics CPI, which is PH by CPI. Okay, now I print this physics CPI in the print. Self is argument. So print student CPI equal to self dot PH by CPI. Okay, so these are the two this is the init definition, and this is another function called print PH by physics CPI. Now I instantiate here SP1. So this is a student, SP1, physics student whose name is Richard, whose roll number is 10, whose CPI is 9. Physics CPI is 9. So print name and print CPI. So I think no, it should be, the output is not written here. So they should print Richard. My name is Richard or something, and CPI will print physics student CPI is 9.0. So physics student CPI is this. I could have printed self dot name has CPI, physics CPI of this. So in fact, I could put a name here as well. Okay, you can beautify it or you can make it better. So what did you learn here? So we have a child class which has more properties than the parent class, but it's inheriting the parent properties. So what we don't need to write, for example, here, I don't need to write print name. The print name is part of the function for student. Already there. So why should you write? In fact, you should not write, because there will be a conflict if you write. Yeah. So child class has its own init method. This init method is own, and that will be instantiated. That will be invoked when every time I instantiate the child class, a child object. So super, this is a function. So super function makes the child class, inherits all the method and properties of its parent. Okay. So this example is exactly same as before, except this line, previous slide. So super dot init name roll number. This line has replaced two lines of the previous slide. What are the two lines of the previous slide? These two lines of the previous slide. Self dot name and self dot roll number. Well, here is two lines, but if you imagine that you had 6 of them, so then it is a good idea to just use the super. So super init and just give the argument. So you don't need to create 6 lines. You're just going to take the definition of the parent class. Okay. And self phy cpi. Okay. Please remember there's no self here. Huh? There's no self here. Self is here. So when the init of the child class comes, the self, but not when the super is coming, super keyword is coming. So if I do this, then I'm saving a line, but for more complex function, we will save more lines. So we have Richard. So this part is exactly the same. So phy student, it has 3 fields now. These are physics CPI. Okay. No, this is not Arjun. This should be copied from the other slide. Okay. So this is an illustration for using child class, and it's useful for creating bigger codes with more classes and stuff like that. For example, we have a vector field. So we may have a vector field, but then we can have incompressible vector field. Okay, so the vector field whose divergence is 0. So that incompressible vector field will be a child class, okay, which inherits from the previous class vector field. So when you specialize, then we have, it's called child class. Okay, so have fun in creating objects. So, well, in this course, we don't need object-oriented programming, but this is introduction, which I hope will become useful for you in future. Thank you.